Hello, my dear children. Welcome to the mathematics class. We have discussed many properties of a triangle as well as a quadrilateral. Okay, my dear children. Now, let us study yet another result which is related to the midpoints of sides of a triangle. Okay, my dear children. In the previous exercise, we have discussed the properties of a quadrilaterals. Now, we are going to discuss the concepts of exercise 8.2. Are you ready to listen the class, my dear children? Right. The exercise at 8.2 is completely based on this midpoint theorem. What is the statement of a midpoint theorem? The line, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. This is the statement of the midpoint theorem. Okay, my children, remember this is statement of the midpoint theorem. In a triangle, let us consider this is a triangle ABC. In this triangle ABC, let us consider E and F are midpoints of these two sides AB and AC respectively. Okay, my children, if we join EF, then this line segment is parallel to BC. This is the statement of the midpoint theorem. Let us prove this statement. Okay, my children. Right. In this triangle ABC, we have to make some more constructions. Let us extend EF. Let us extend EF. Okay, my children. And let us draw a parallel line. Let us draw a parallel line. Let us draw a parallel line CX, which divides this EF extended line at D. Okay, my children, let us draw that we have to construct. To prove this theorem, we have to do some more construction. This is a construction. We have extended EF and we have drawn through the point P, we have drawn a line parallel to AB through the point C. Okay, my children, right. In the adjacent figure, in the adjacent figure, in triangle ABC, let E and F, are midpoints of the sides, AB and AC, respectively. Okay, my children, we have taken like this. E and F are the midpoints of these two sides, AB and AC, respectively. Now we have to prove that. What is to be proved? We have to RTP required to prove. What is to be proved? EF is parallel to BC. We have to prove that this line EF is parallel to BC. Now let us do the construction. Let us construct a line. Extend EF. Extend EF. Okay, my children. Extend EF and draw a line through C. Draw a line through C parallel to AB, intersecting EF extended at EF intersecting extended yet D. We have drawn a parallel line CX. It is parallel to AB and it is intersecting that extended EF at point D. Okay, my children, understood? Right. Now come to this proof. We have to prove that EF is parallel to BC. Now if you observe, there are two triangles. This is one triangle and this is another triangle. We got two triangles. Isn't it or not, my children? Now in triangle EFA, FAE or FAE, in triangle FAE and triangle FCD. Okay, my children, FCD. Here AF is equal to FA is equal to FC. FA is equal to FC. Since F is okay, make sure this side FA is equal to these two sides are equal. Isn't it or not, my children? Here this angle and this angle are equal with vertically opposite angles. Angle AFE, angle AFE is equal to angle DFC or CDF, angle CDF, vertically opposite angles. Okay, my children, understood this step? These two angles are vertically opposite angles. Now we have drawn this line CX is parallel to AB. So then what you get here? This angle is equal to this angle because they are alternate interior angles. AC is the diagonal. If you take AB is parallel to CD and this AC is a transversal, then this angle and this angle is what are the two angles said to be? Alternate interior angles. Angle FAE is equal to angle FCD. Alternate interior angles. For the parallel lines, AB and CD with AC transversal. Okay, my children, understood this point, understood this step. These two angles are equal. So in these two triangles, we compared these three parts: angle, side, angle. Two angles and included side is equal to the corresponding two angles and included side in the second triangle. Therefore, these two triangles are said to be congruent. Therefore, triangle FAE is congruent to triangle FCD by ASA congruence rule. Understood this step, my children? By using this congruence rule, we proved here this triangle is congruent to this triangle. Understood this step, my children? Right. Here we have proved that these two triangles are congruent triangles. Then by CPCT, we can say that CD is equal to EF. Isn't it or not, my children? Yes or no? Therefore, CD CD is equal to AE or EA by CPCT. By corresponding parts of congruent triangles, CD is equal to EA. But here A is equal to EB because E is the midpoint of AB. Isn't it or not, my children? This implies CD is equal to EB. CD is equal to EB because EA is equal to EB. Midpoint E is the midpoint of E is the midpoint of AB. Understood this step, my children? So we proved here CD equal to BE. So in this quadrilateral EBCD, in this quadrilateral EBCD, B is parallel to CD. We have constructed like that, and these two sides are equal. CD equal to BE. Then this quadrilateral is said to be a parallelogram. Okay, my children. So quadrilateral in quadrilateral EBCD, CD is parallel to BE. CD is parallel to BE, and CD is equal to BE. From this result, CD is equal to EB or BE. This implies we can say that EBCD is a parallelogram. Because there is a property of a parallelogram. In a quadrilateral, if any two sides are parallel and they are equal, any one pair of opposite sides, only one pair of opposite side parallel and equal, then automatically the quadrilateral is a parallelogram. Okay, my children. Then ED is parallel to BC. Isn't it or not, my children? This implies ED or EF is parallel to BC. EF is parallel to BC, and if you observe here, EF is half of ED. Isn't it or not, my children? EF is equal to half of ED. Half of ED because by CPCD EF is equal to FD. EF is equal to FD by CPCT. Okay, my children. That is equal to EF is equal to half of ED is nothing but BC because this is a parallelogram. Opposite sides are equal. Isn't it or not, my children? BC. So this third side, this EF is parallel to this third side, and moreover this is length is half of this third side. Okay, my children, remember this result also. This result is also very important in solving the problems in the exercise 8.2. Okay, my children, this is about midpoint theorem. Understood, my children? Right. The concepts of exercise 8.2 were completed. Only one concept, only one point, that is midpoint theorem. Based on this midpoint theorem, we solve the problems in the exercise 8.2. 2. Okay, my children. See the page number 150 in the textbook. Come to the question number 1. First question. ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA. See here, this is a quadrilateral ABCD and P, Q, R, S. These are the midpoints of these ABCD, AB, BC, CD and DA respectively. Here AC is a diagonal. AC is the diagonal. Show that SR is parallel to AC. You have to prove that this line is parallel to AC and SR is equal to half of AC. Next one, PQ is equal to SR. You have to prove that PQ is equal to SR. Next, third one, PQRS is a parallelogram. We have to prove these three parts. Okay, my children. Right. Come to the solution part. Understood the question, my children? Right. First of all, let us write the given data. Given, what is given? ABCD is a quadrilateral. Whatever given here, ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA respectively. And AC is a diagonal. AC is a diagonal. This is a given data for us. What is to be proved? Required to prove these three parts. First part, SR. SR is parallel to AC and SR is equal to half of AC. Next, second part. What is the second part? PQ is equal to SR. Next, third part. PQRS is a parallelogram. Understood these three steps, my children? We have to prove these three parts. Here, this is a given data for us. Okay, my children? See here. Come to the proof. If you observe in triangle DAC, S and R are, these 2 points are midpoints of D and DC. Yes or no, my children? Yes, these 2 points are midpoints of these two sides, DA and DC. Okay, my children. Then, what can you say about this line segment SR? This line segment SR is parallel to AC. And this is half of this third side AC by midpoint theorem. Okay, my children, do you remember that point? Right. So, in triangle, let us take this first one. We are proving that in triangle DAC, S and R midpoints of the sides DA and DC. DA and DC respectively. So in this triangle DAC, forget this remaining part. In this triangle, focus on that figure. triangle DAC. In this triangle DAC, these 2 points are midpoints of these two sides D and DC. Then we can say that SR is parallel to AC. Okay, my children, yes or no? SR is parallel to AC, and SR is equal to, this is half of the third side. This line segment is parallel to the third side and it is half of the third side. Previously I told you, we have to remember that result also. Okay, my children. So by the midpoint theorem. By midpoint theorem. Okay, my children, understood this step? Right. So the first part of the question is completed. It was proved. Now come to the second part of the question. What should be proved? PQ is equal to SR. Okay, my children. We have to prove that PQ is equal to SR. Now, to prove this statement, let us take BAC, triangle BAC. In triangle BAC, P and Q are midpoints of the sides BA and BC respectively. Yes or no, my children? P and Q are, these 2 points are midpoints of BA and BC respectively. Then what can you say about PQ? PQ is parallel to AC. This implies PQ is parallel to AC and PQ is equal to half of AC by midpoint theorem. By midpoint theorem. Understood this step, my children? By using the midpoint theorem, we wrote this step. PQ is parallel to AC and PQ is equal to half of AC. In the first part of the question, we have proved that SR is parallel to AC and SR is equal to half of AC. Isn't it or not, my children? Therefore, SR is equal to half of AC and PQ is also half of AC. Both are half of AC. Then this implies, what can you say about these two? SR is equal to PQ. Isn't it or not, my children? This implies PQ is equal to SR. So this is also proved. Understood this step, my children? Right. Now come to the third one. To prove PQRS is a parallelogram, we have to prove that this quadrilateral PQRS is a parallelogram. In this parallelogram, we have proved that PQ is parallel to AC, okay, my children, and AC is parallel to SR, and then these two are also equal. So here in parallelogram, in the quadrilateral, PQRS, PQ is parallel to AC. PQ is parallel to AC and SR is parallel to AC. This implies PQ is parallel to SR. Can we write this result or not, my children? This line is parallel to AC and this line is parallel to AC. Therefore, these two lines are also parallel to each other. Okay, my children. So in this quadrilateral, these two lines are parallel to each other. This pair of opposite sides are parallel, and moreover they are equal. PQ is equal to SR. Okay, my children, and PQ is equal to SR. SR. We have proved. The third part of the question, we have proved PQ is equal to SR. So in the quadrilateral, in any quadrilateral, if a pair of opposite sides are parallel and equal to each other, then the quadrilateral is said to be a parallelogram. Okay, but this is also a property of a parallelogram. Therefore, PQRS is a parallelogram because a quadrilateral is a parallelogram. A quadrilateral is a parallelogram if a pair of opposite sides are parallel and parallel and equal to each other. Okay, my children, by using this property, we concluded that this quadrilateral is a parallelogram. Understood this step, my children? Right. So, hence proved. We have proved all the three parts. Hence, okay, my children, understood? Right. Now come to the next question. Question number 2. ABCD is a rhombus and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. Observe this figure, my children. ABCD is a rhombus. In this rhombus, P, Q, R, S, these 4 points are midpoints of these sides AB, BC, CD and DA respectively. Understood this diagram, my children? Right. Show that the quadrilateral PQRS is a rectangle. Then we have to prove that PQRS is a rectangle. Okay, my children? Right. First, let us write the given data. In the adjacent figure, ABCD is a rhombus. ABCD is a rhombus. Immediately you have to write the properties of rhombus. What is the properties of rhombus? AB is equal to BC is equal to CD is equal to DA. Yes or no, my children? All the sides of a rhombus are equal. You have to remember these points, the properties of rhombus. And the diagonals AC and BD, they are bisecting each other. Diagonals AC and BD bisect each other at right angle. At the point O. Let us consider the diagonals AC and BD are bisecting at a right angle. In a rhombus, diagonals of a rhombus are perpendicular to each other. and they bisect each other at right angles. Okay, my children, do you remember these properties of diagonals of a rhombus, my children? This is the properties of sides of a rhombus. By using that property, we wrote these two steps. Okay, my children, right. And also given that PQR and S are the midpoints of the sides, AB, BC, CD and DA respectively. Whatever the given data, I wrote this step. Understood this step, my children? Right. Now, what is to be proved? We have to prove that it is a rectangle. PQRS required to prove PQRS is a rectangle. Okay, my children. So let us take the triangle DAC. Triangle DAC. In triangle DAC, these two are midpoints of DA and DC respectively. Then automatically SR is parallel to AC and it is half of AC. By the midpoint theorem, we can write. Isn't it or not, my children? So in triangle DAC, SR is parallel to AC and SR is equal to half of AC by the midpoint theorem. By the midpoint theorem. By the midpoint theorem, we wrote this step. Understood this step, my children? Similarly, in triangle BAC, these 2 points are midpoints of these two sides, B and BC respectively. We have already taken midpoints. Okay. Then PQ is parallel to AC and PQ is equal to half of AC by the midpoint theorem. So here this statement is also written. This step is also written by using the midpoint theorem. Okay, my children, understood this step. So here SR is parallel to AC. Here PQ is also parallel to AC. What you say here? Therefore PQ is parallel to SR and PQ is equal to SR because SR is equal to half of AC and PQ is also half of AC. Both are equal. So these two are also equal. Yes or no, my children? Right. So in this quadrilateral PQRS, this result already we proved in the first question. We are using the same result here. So PQRS, in this quadrilateral PQRS, PQ is parallel to SR and PQ is equal to SR. Then this quadrilateral is said to be a parallelogram. Therefore, PQRS is a parallelogram. Because we wrote that reason. Because a pair of a quadrilateral is a parallelogram if a pair of opposite sides are parallel and equal. In a quadrilateral, if a pair of opposite sides are parallel and equal, then the quadrilateral is said to be a parallelogram. By using this property, we wrote this step. Okay, my children, understood this step? We have proved all this part. We have already proved in the question number 1. Do you remember that point, my children? Right. For our convenient, let us take this point is E and this point is F. The point of intersection of SR and OD is equal to E, and QR and OC is equal to F. Let us consider the points of the point of intersection of OD and SR is E, and OC and RQ, and the point of intersection of OC and RQ. For our convenient, we have taken these 2 points. Okay, my children. Here, ER is parallel to OF. Okay, my children. FR is parallel to OE. In the quadrilateral, OFRE, we have already proved AC is parallel to SR. Okay, my children. ER is parallel to OF. FR is parallel to OE. Isn't it or not, my children? This implies we say that OFRE is a parallelogram. Okay, my children. This pair of opposite sides are parallel, and this pair of opposite sides are also parallel. So this small OFRE is a parallelogram. In this parallelogram, angle EOF is 90 degrees. Angle EOF is equal to 90 degrees because the diagonals, they are intersecting at right angles at O. Because the diagonals AC and BD at right angles at O. Diagonals of a rhombus. These 2 are diagonals of a rhombus. We know that diagonals of a rhombus bisect each other at a right angle. By using this property, we wrote this one. So in this parallelogram, angle OF is 90 degrees. So automatically this is a rectangle. This implies OFRE is a rectangle. In a parallelogram, if any one angle is 90 degrees, then the parallelogram becomes a rectangle. Okay, my children. Similarly, in this PQRS parallelogram, this is 90 degrees, this 90 degrees, this is 90. Automatically this is 90, this is also 90, this is also 90. So here also in the PQRS parallelogram, this angle is 90. So automatically opposite angles of a parallelogram also 90. So this 90 and all the angles of a Parallelogram also 90. Angle QRS is equal to 90 degrees. Implies PQRS is a rectangle. Hence proved. Okay, my children, understood? Right. You please try the question number 3 and question number 4. Will you try the question number 3 and question number 4 yourself, my dear children? Try it. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right.